All right, let's crush another Mtel question. This one says, use the diagram below to answer the question that follows. We've got these 3 squares with some shaded squares inside of them. So the square is divided into 9 congruent squares, and the center square is shaded, as shown in the diagram. Then, each of the unshaded squares is divided into 9 congruent squares, and the center square is shaded. If this process continues, which of the following expressions represents the fraction of the original square that will be shaded? So we've got something called a fractal sequence or a fractal pattern appearing here, where the same pattern that happened in stage 1 happens in smaller iterations as you move out from the center, right? So in stage 1, we can see that 1 out of 9 of the boxes are shaded, which is why A, B, C, and D have 1/9 at the beginning, because that's going to remain shaded the whole time. So 1/9 of this whole box is always going to be shaded, and then that same pattern is going to happen in each of the smaller boxes around that box. And you can see that there's 8 of those, right, in stage 2. So surrounding the center box, there are 8 white boxes that the center box gets shaded in. And that center box is going to be 1/9 of the original 1/9 of stage 1. So 8 times 1/9, right? So if we take a look at answer C here, we have 1/9, which is stage 1, plus 8 times 1/9 squared. 1/9 squared is 1/81st. And each of these tiny little boxes in stage 2 is 1/81st of the whole box. And 8 of them are shaded, so we get 8 of those tiny little boxes that are 1/81st of the whole thing. So now we've got stage 2 represented in the first 2 terms in C right here, right? If we think about adding a stage 3, the same thing is going to happen, but the boxes are going to be smaller, and instead of being 1/81st, they're going to be 1/9 to the 3rd power, because they get 1/9 smaller than the time before, and there's going to be 8 times as many of them, and this pattern just persists. So we can just raise 8 to a new power, add 1 to that power, and then multiply by 1/9 raised to a higher power, and that'll give us the smaller iteration each time. And that's the pattern that sort of is produced by the situation. So the answer to this one is C.